The three main books that discuss surveying are Principles and Practices of Commercial Construction, Carpentry and Building Construction, and The Pipe and Excavation Contractor. Let's go over some common words and abbreviations you should be familiar with. It all starts with the benchmark, which will have the abbreviation BM. It's the point of known elevation, a basic starting point, from which measurements in building layout can be made using a transit or level. A benchmark is a point of known elevation, established by registered survey. Also called a point of reference, POR, or a datum point. Locating a benchmark. To lay out a building using a transit or a level, you must first have a basic starting point. The starting point, from which a measurement can be made, is usually called the benchmark. The three main books that discuss surveying are Principles and Practices of Commercial Construction, Carpentry and Building Construction, and The Pipe and Excavation Contractor. Let's go over some common words and abbreviations you should be familiar with. It all starts with the benchmark, which will have the abbreviation BM. It's the point of known elevation, a basic starting point, from which measurements in building layout can be made using a transit or level. A benchmark is a point of known elevation, established by registered survey. Also called a point of reference, POR, or a datum point. Locating a benchmark. To lay out a building using a transit or a level, you must first have a basic starting point. The starting point, from which a measurement can be made, is usually called the benchmark. Let's look at some types of surveying instruments. Optical level is a telescope that mounts to a tripod. Line of sight is exactly level no matter how the scope is rotated. Level transit. Besides turning in a horizontal plane, a level transit will also tilt through a vertical arc, up to 45 degrees from horizontal position. Theodolite is a transit that reads horizontal and vertical angles electronically. The telescope on a theodolite may be rotated 360 degrees in a vertical plane. Gauge rod, also known as a surveying rod or a measuring rod. Height of instrument. Surveyors find the height of the instrument by reading a measuring rod held on a benchmark. They add that reading to the known elevation of the benchmark to determine the height of the instrument, which is abbreviated HI. Here's an example. A benchmark of 250 feet above sea level, plus a rod reading of 2.25, equals an instrument height of 252.25. That's step 1. Determine the instrument height by taking a back sight on the benchmark. Back sight. In surveying, it is the reading taken on the last control point in a series which has been established before sighting on the next point. Think of it as looking backwards. The very first sighting on the benchmark is technically a back sight. Foresight. In surveying, it's the sighting taken on a point in a traverse to establish its elevation with respect to a known elevation. Think of it as looking forward. Other terminology to know. Hub is a small stake driven into the ground to identify some reference point. Near the hub, will be a reference stake, which identifies the hub's elevation. You may see a question about reading a reference stake. The circle is the offset, and the C is the cut from the hub. Monuments. The boundaries of the lot on which a building is to be constructed should be established by markers called monuments. Topographic maps. Contour. A contour line represents points of equal elevation. Closely spaced contour lines indicate a steep slope, while contour lines spaced far apart indicate a gentle slope. Contour lines that form a closed loop represent either a summit or a depression. Okay, let's get started. We need to excavate for a slab on grade. Before we pour the concrete, we need to confirm the subgrade is at the correct final elevation. The question reads, the benchmark is at an elevation of 125 feet, and the backside is 5 feet above the benchmark, and the foreside is 7.5 feet. What is the subgrade elevation? We start by setting up the theodolite, somewhere between the benchmark and the final elevation. For step 1, we take a backside rod reading on the benchmark. In this case, the backside is 5 feet. An easy way to remember step 1 is to add your B's together. This gives us the HI, height of instrument, at an elevation of 130 feet. Now that we know the height of the instrument, we can move to step number 2. Next, we take a foresight rod reading. In this case, the foresight rod reading is 7.5 feet. That leaves us with a final subgrade elevation of 122.5 feet. On the exam, the numbers will be more difficult. You'll definitely need a calculator. They can ask these questions a few different ways. Let's try another one, but this time we're asking for the foresight. Question 2. If the slab is 4 inches thick, what is the foresight rod reading from the TOS, top of slab, to the HI, height of instrument? The subgrade is at 122.5 feet. 4 inches converted to feet is equal to 0.33 feet. Add the slab thickness, 0.33, to the subgrade elevation, 122.5, equals a TOS at elevation of 122.83 feet. The last step is to find the difference between the instrument height of 130 feet and the top of slab, 122.83 feet. The foresight rod reading should be 7.17 feet. We're doing really well. Let's try another one. But this time, let's try measuring off of a hub. Question 3 says, the reference stake by the hub is marked C4.08. The hub rod reading is 5.17. What is the final elevation of the finish cut? Step 1 is to add the cut figure 4.08 to the hub reading of 5.17. This gives us a required cut below the instrument height of 9.25 feet. Let's excavate. Step 2 is to subtract the 9.25-foot cut from the 8 shy of 130-foot elevation, which gives us a finish cut elevation of 120.75. Hubs are commonly used in underground utilities and road work and paving. It's not uncommon to see a question about a reference stake or hub. Feel free to watch the video again. Let's try to answer a few surveying questions. Put your knowledge to the test. Good luck.